Hello everyone, my name is David Asmilis and I'm a development lead of iModel Transformation Service here at Bentley Systems. And in this webinar, we'll cover what is the transformation service, what it is used for, what capabilities it has, and go through some demos on how to actually configure and run the transformations to achieve a result. So transforming the data is instrumental in many digital twin workflows, such as data alignment, geometry simplification, content distribution, and much more. And the transformation service provides ability to transform iModel data. So in the context of the transformation service, the source and the target is always an iModel. The service itself is fully configurable. It can be found under the synchronization API group. And if you would go into the documentation, synchronization and exports, you can find all the transformation service endpoints under the transformation style. So the transformations API itself supports multiple endpoints. Um, General workflow would be to create a specific configuration for the transformation depending on the use case. Currently, we expose two transformation types, which is combining of physical models for uh, viewing performance optimization within the iTwin viewers. This transformation is used when there's a huge amount of data in an iModel and when bridging multiple uh, data sources into a single iModel, what generally happens is that underneath the iModel, the multiple models are being created, and rendering these kind of views in a web browser results in having very low frame rate. To actually work around this, this transformation picks up the models and merges them together. To better represent this, I'll open the information hierarchy window of the iModel. And as you can see, the physical partition correlates and is related to physical models. And these are the physical models that are being brought into the iModel when huge amounts of data are being connected to the iModel. So the first transformation that we'll go through combines the first level of physical models into a single model. Okay, so let's switch over to a design review application. I have here a demonstration model of a station. And if we would open the model tree, we can see that the metro station model has multiple submodels underneath it. It's not a huge iModel, just to reduce the time necessary to run the transformation itself. We'll use it just as an example. So let's say that this iModel would have a lot of models within it and would have some viewing performance problems, and we would like to run the transformation against it. So what I would do is let's go and list all of the iModels inside this project, and let's create a placeholder, uh, combined physical models. This iModel will serve as a destination to put in the transform data. Okay, so we have source iModel that will use the data from and an empty target iModel. Now we can go into developer.bentley.com and try configuring the transformation and actually running it. So once we're in the transformations API, let's go under reference and create combined physical models configuration. So this transformation requires two transformation type specific parameters. It's the number of models we want to have in the transformed iModels, and if we would like to simplify geometry or not. Geometry simplification is an optional parameter indicating that if geometry simplification should be used or not. What this does, it's transforming parasolids into meshes. It reduces the accuracy, but by default, this option is set to false, and without it, the transformation runs for shorter amount of time. So let's try out this transformation, and let's pick the authentication. I've already logged in into my account, so the bearer token is automatically appended here to the header. And let's go through the body parameters that has to be specified. So the transformation name is basically a free text that you can specify, displaying the transformations and configurations in your own UI. Um, for the source project ID, this part indicates the source data. It's the combination of the project ID and iModel ID of the data that we want to transform. And the later pair is for the target iModel. So as you can see, these might be placed in separate projects. The user that's actually running the transformation must have permissions to both iModels, but for our demonstration purposes, we'll keep it a bit simpler and have it on the same project. Okay, so from the URL, I can pick my project ID. Let's select it. Okay, so this is the project ID of our data, and since we're using the same, let's put it as same values. And I'll paste in the source iModel ID and newly created placeholder also into the target iModel ID. The comment property here is used for submitting chain set and what information is going to be displayed there. And in the transform parameters is the transformation type specific properties. It's the number of models and geometry simplification. Just for demonstration purposes, let's skip on geometry simplification and specify that the number of models should be 1. And let's try executing the request. And as you can see, we get a 201 created. So this is only creating a configuration itself. The transformation is not currently running. To actually run the transformation, we have to go into a separate endpoint that triggers the transformation. If we would go into tryout, you can see that the request body requires a configuration ID. This is a two-step process to run the transformations simply because the transformation service supports processing changes. For example, after initial transformation is completed and new data is added to the source iModel, we can run the transformation for the second time and it will process the changes on the source iModel into the target and not process the whole iModel as an initial transformation. So once we specify the configuration ID, let's execute it, and we get a 201 created with a transformation ID, and we can see some information. The current status, it's in created status. This means that the job didn't start yet, but it's been scheduled, and we don't have the progress data yet since the iModel is not loaded. If we would go into get transformation endpoint and try querying back the transformation data. Okay, wrong endpoint. It's get transformations. Try out. It requires the transformation ID parameter, which we can paste and execute. As we can see, the status currently is in started. There are no elements currently processed, but we know the total element count in the source iModel. So we can query for multiple times and see that the process is being updated. We can see that it's already 10,000 out of 14,000 elements that are being processed. Let's query and give a bit more time, and we can see that that transformation status is already succeeded. So we can go into our target iModel placeholder and refresh the window. We can see already uh, a change set pushed. And if we want to view the data, let's quickly create a new named version here. Okay, once the named version is created, let's open. Right from the start, we see that only a single model is available here. Let's wait a bit for the initial loading. And if we open the model tree, we'll already see that there's a single model here with all of the data underneath, and we have the same data here. So that's the physical model combination for viewing optimization transformation. Another transformation type that we currently support is called filter by view definition. So a view definition is basically a concept of an iTwin viewer that is able to filter out or enhance the viewing experience of the model that is currently being opened. So for example, once the iModel is open here, we can hide certain elements from the iModel and leave out only the required information. So let's say that we're only interested in equipment. So we can hide the necessary elements from the model tree, and we can go into saved views and create a new saved view. Let's say it's equipment. All right. So once this is saved, um, the iTwin UI uh, has tools to work with views, and the data can be extracted using iModel GS libraries. Uh, let's quickly jump into the developerbentley.com. Let's go into transformations API reference and open up the filter by view definition. So as it currently stands, the filter by view definition currently supports two data points. It's an array of models and categories. And both of these data points are stored inside the view definition that you create within the iTwin viewer. So if we would go back into the iModel and open up for viewing, we can inspect the network traffic while loading here and sniff out the view definition that is being saved here. So we have multiple saved views here, but the ones the one we created is called equipment. We can go through here and open up a preferred editor of choice and just inspect what we have here. Let's search for equipment, and we can see that there's a saved view with equipment. And we can see that there's a category selector props and the whole categories array here. Let's save that. And also we have models array. As you can see, these are two arrays that are being saved in the view definition, and the iModel viewer knows how to display the iModel. So what we can do is supply this information to the filter by view definition transformation. Let's authenticate once more. And as you can see, the transform parameters contain two properties. It's models and categories that we can provide here. Okay, let's copy the models array. Okay, we have models here, and let's jump into categories and save it up. And categories. Okay, models and categories are specified. What is left is to supply the source and target iModel data. Okay, let's copy out necessary information. Once again, the source and target projects stay the same. And let's create a new filter by view definition demo iModel. And copy out the iModel ID from the URL. Okay, we have target. Okay, and let's copy out the source iModel. Okay, data stays the same. Let's try submitting. Execute. We have a created state, and the process from here is the same. Let's close it out. Let's submit a new transformation. Let's authenticate. And provide a configuration ID. There's a possibility to use specify a chainset ID of the source iModel to use. If we are not specifying it by default, we're using the latest chainset. Okay, as we can see, the transformation was created. And once again, let's try retrieving the transformation data back to track the progress. Okay, we see that it already succeeded. Let's quickly open up the newly created iModel and see what data is in here. Let's create a named version for viewing. Okay, the named version already created. Let's open this up. Okay, so the iModel loaded, and as we can see, there's only equipment left here. If I open the model tree, there's nothing additionally inside the iModel. And yeah, that's the filtering capability. There's additional properties in filter by view in view definitions. It's there's additionally uh, per category visibility, per model category visibilities. We also plan to add support for uh, clip box transformations, which would allow to basically select a selection box inside a viewer and do the transformation based on that. Um, Also, we're planning to expose multiple iModel merging transformation in the future, which would allow to combine multiple data sources from two or more iModels. We're also working on a data alignment transformation, which would basically allow you to remap data from a source schema into the target schema. I cannot give an estimate on when it is going to be available, but we're currently working on all of these efforts. I've currently showed you the process of how to actually configure and run the transformation from the developer.bentley portal and going through the API reference. What you can additionally do is once you're inside the transformation service documentation, you can go into the tutorials section and open up a tutorial that we currently have. uh, it's a it basically runs through the filter by view definition transformation, but with some additional steps of how to actually register an application to get a valid token to be able to call the transformation service APIs and not use the try it out functionality of the developer.bentley.com portal. Also, some additional information on what is a view definition, how to get models and categories with EC SQL queries that you could run through Bentley console web application. And it runs through the whole process of how to create a configuration, how to create a transformation, and how to wait for the whole progress to actually finish. Another thing that might prove useful is the transformations sample created. This is basically a sample iTwin viewer application which displays two iModels at the same time. It's a source iModel before a transformation and the target iModel after the transformation. So you can use this transformations sample um, to get a hang of how to use the transformations API and how to visualize the results of it. Also, the necessary logic to have a balanced multiple viewport viewer. Um, but by what I mean by saying balance is that both of them would be synchronized between each other, and moving a single viewport would result in moving uh, both of them. You have all the necessary code available here in the TypeScript. You can go through and review of what is necessary from the technical side to actually achieve that. All right, I think that was everything for this webinar. Thanks everyone for participating, and if you have any questions, there's a Q&A session at the end.